So this is 2C here. Carlos pushes a block of mass M across a rough horizontal surface. That roughness means there's going to be friction at a constant speed. So in other words, there is no acceleration. Applying a force F directly to the right. So first thing is, let's give a free body diagram. So clearly there's going to be some gravity. So I'll draw it 1, 2, 3, 4 down. No reason, just looks good. And I'm going to call that force of gravity. We will have a normal force counteracting it back up. 1, 2, 3, 4, up. I know they have to be equal because it's not accelerating in the y. I'll call that normal force. We have a push to the right. 1, 2, 3, 4, 5. No reason, just drawing it that way. I will call this force applied. And because it has no acceleration, then I know that there's got to be some friction. 1, 2, 3, 4, 5. That is equal to the applied force. So whatever you drew this has to be the same value. And whatever you drew the applied force, the force of friction has to be the same value there. So next thing they want you to do is follow their equations here and make an argument about how you know that the normal force and the force of gravity have to be the same value there. Now this is pretty explicit. This is more than I think you'd have to actually do, but let's practice it and be thorough the first time here. So what they want you to do is write the words here. They've given you the equations, and so basically tell what the equations are saying here. So you always start with Newton's second law. In this case, notice they've specified it in the y direction. So sum of forces in the y and acceleration in the y. They say we start with Newton's second law, which says the sum of the forces exerted on an object is equal to the object's mass times the object's acceleration. Then you need to say the sum in the y, is there's only two forces in the y. And the way we label them is like this. It is the normal force up, and it's the force of gravity down. So we've replaced the sum with the things that actually sum up to create that. Then here we know that acceleration in the y is equal to 0. So that's what they've indicated here. And I think this is the step that's a little bit redundant. They've just, since a is 0, the whole side is 0 there, obviously. And then if you solve for this, add the mg to the other side. So the normal must equal the weight, or the force of gravity on the mass. So this seems super explicit, but just to be clear, that's how you would maybe want to make your argument there in terms of being very clear. So last part here is they say that Carlos gets tired of pushing and instead begins to pull with a force F pull at an angle to the horizontal. The block slides along the rough horizontal surface at a constant speed again. And so Blake says the velocity of the block is constant, so the net force exerted on the block must be 0. That's true. So it has no constant velocity, no acceleration, no net force. Thus, the normal force equals the weight, and the force of friction equals the applied force F pull. Well, in this case here, it's not quite as simple as it seems, because we actually have a vector here, and it's got components. So we could call this component right here F pull X, for example. And then we have a vertical component here. We could call that F pull Y. So now let's actually state what must be equal here. It's right that all the sides have to balance out, but we could write this now. We know that F pull X equals the force of friction. So that's really the sideways force, not the pull, just the X component of it. And then we know that the normal force up plus the pull in the Y direction up, there's two up forces here, the normal and the pull, is equal to the weight. So in this case, since these two things together equal the weight, the normal force is not equal to the weight in this case. We get so used to doing that, but it's actually only true if you're just sitting on a level surface or pushing to the side. But the moment you get another vertical force involved, the normal force will not be equal to the weight. Here, the normal force and the pull in the y direction are equal to the weight. So then it's just a general part. Get used to this. Like, did you answer it directly? What was wrong with Blake's question? Yes. Did you state laws of physics that are always true? Yes, that's the second law that we use there. Connected the laws of physics to the specific situation. Yes, we broke apart the F pull into its components, and we used our physics vocabulary there.